The .223 Remington is a cartridge with almost the same external dimensions as the 5.56A, 45mm NATO military cartridge. The name is commonly pronounced either 223 or 223. It is loaded with a 0.224-inch diameter jacketed bullet, with weight ranging from 40 to 90 grains, though the most common loading by far is 55 grains. While the external case dimensions are very similar, the .223 Remington and 5.56A, 45mm differ in both maximum pressure and chamber shape. The maximum and mean pressures for some varieties of the 5.56 exceed the SAAMI maximum for the .223 Remington, and the methods for measuring pressures differ between NATO and SAAMI. The 5.56 chamber specification has also changed since its adoption, as the current military loading uses longer, heavier bullets than the original loading. This has resulted in a lengthening of the throat in the 5.56 chamber. Thus, while .223 Remington ammunition can be safely fired in a rifle chambered for 5.56A, 45mm NATO, firing 5.56 ammunition in a .223 Remington chamber may produce pressures in excess of even the 5.56 specifications due to the shorter throat. History: the .223 Remington is a cartridge that is ballistically in between its predecessors, the .222 Remington, and the .222 Remington Magnum. The .223/5.56 was developed to fit the action length of the new M16 service rifle. The .223/5.56 quickly became popular as a civilian cartridge because of the availability of brass, and the chambering of commercial varmint rifles in that caliber. Shortly after military acceptance of the M16, the semi-automatic version, the AR-15 became available, making the .223 cartridge even more popular. Cartridge dimensions: the .223 Remington has 28.8 grains cartridge case capacity. .223 Remington maximum CIP cartridge dimensions. All sizes in millimeters. Americans would define the shoulder angle at alpha/2 equals 23 degrees. The common rifling twist rate for this cartridge is 305 ohm, 6 grooves, a lands equals 5.56 mm, a grooves equals 5.69 mm, land width equals 1.88 mm, and the primer type is small rifle. According to the official Commission Internationale Permanente pour les Armes Feu Portatifs guidelines, the .223 Remington case can handle up to 430 ohm per piezo pressure. In CIP-regulated countries, every rifle cartridge combo has to be proofed at 125% of this maximum CIP pressure to certified for sale to consumers. This is equal to the NATO maximum service pressure guideline for the 5.56A, 45mm NATO cartridge. The SAAMI pressure limit for the .223 Remington is set at 379.212 ohm per piezo pressure. Uses: the .223 Remington is one of the most common rifle cartridges in use in the United States, being widely used in two types of rifles, varmint rifles, most of which are bolt action and commonly have 1-12 rifling twists suitable for bullets between 38 to 55 grains, and semi-automatic rifles such as the AR-15 and the Ruger Mini-14, which are commonly found to have twist rates of 1-7, 1-9, or 1-8. The semi-automatic rifle category is often used by law enforcement, for home defense, and for varmint hunting. Among the many popular modern centerfire rifle cartridges, .223 Remington ammunition is among the least expensive and is often used by a wide range of target shooters, particularly in the service rifle category or three-gun matches. The .223 is also used in survival rifles. .223 Remington vs 5.56A, 45mm NATO. The .223 Remington and 5.56A, 45mm NATO cartridges and chamberings are similar but not identical. While the cartridges are identical other than powder load, the chamber lead, that is the area where the rifling begins, is cut to a sharper angle on some .223 Remington commercial chambers. Because of this, a cartridge loaded to generate 5.56A, 45 mm NATO pressures in a 5.56A, 45 mm NATO chamber may develop pressures that exceed SAAMI limits when fired from a short lead .223 Remington chamber. Brass case. The dimensional specifications of 5.56 NATO and .223 Remington commercial brass cases are identical. The cases tend to have similar case capacity when measured, with variations chiefly due to brand, not 5.56 versus .223 designation. The result of this is that there is no such thing as 5.56 brass, or .223 brass. The differences in the cartridge's lie in pressure ratings and in chamber lead length, not in the shape or thickness of the brass. Pressure. CIP defines the maximum service and proof test pressures of the .223 Remington cartridge equal to the 5.56A, 45 mm NATO, at 430 MPa. This differs from the SAAMI maximum pressure specification for .223 Remington of 380 MPa. Due to CIP test protocols measuring pressure using a drilled case, rather than an intact case with a conformal piston, along with other differences. NATO uses NATO EPVAT pressure test protocols for their small arms ammunition specifications. Because of these differences in methodology, the CIP pressure of 430 MPa is the same as an SAAMI pressure of 380 MPa. Which is reflected in U.S. military specifications for 5.56A, 45 mm NATO, which call for a mean maximum pressure of 55,000 psi. These pressures are generated and measured using a chamber cut to 5.56A, 45 mm NATO specifications, including the longer lead. Firing 5.56A, 45 mm NATO from a chamber with a shorter .223 Remington lead can generate pressures in excess of SAAMI maximums. Chamber. The 5.56A, 45 mm NATO chambering, known as a NATO or mil-spec chamber, has a longer lead, which is the distance between the mouth of the cartridge and the point at which the rifling engages the bullet. The .223 Remington chambering, known as SAAMI chamber, is allowed to have a shorter lead, and is only required to be proof tested to the lower SAAMI chamber pressure. To address these issues, various proprietary chambers exist, such as the welded chamber or the ARMA light chamber, which are designed to handle both 5.56A, 45 mm NATO and .223 Remington equally well. The dimensions and lead of the .223 Remington minimum CIP chamber also differ from the 5.56A, 45 mm NATO chamber specification. Using commercial .223 Remington cartridges in a 5.56A, 45 mm NATO chambered rifle should work reliably, but until recently, it was believed this was less accurate than when fired from a .223 Remington chamber gun due to the longer lead. Although that may have been true in the early 1960s when the two rounds were developed, recent testing has shown that with today's ammunition, rifles chambered in 5.56 can also fire .223 ammunition every bit as accurately as rifles chambered in .223 Remington, and the 5.56 chamber has the additional advantage of being able to safely fire both calibers. Using 5.56A, 45 mm NATO mil-spec cartridges in a .223 Remington chambered rifle can lead to excessive wear and stress on the rifle and even be unsafe, and SAAMI recommends against the practice. Some commercial rifles marked as .223 Remington are in fact suited for 5.56A, 45 mm NATO, such as many commercial AR-15 variants and the Ruger Mini 14, but the manufacturer should always be consulted to verify that this is acceptable before attempting it, and signs of excessive pressure should be looked for in the initial testing with 5.56A, 45 mm NATO ammunition. It should also be noted that the upper receiver and the lower receiver are entirely separate parts in AR-15 style rifles. If the lower receiver has either .223 or 5.56 stamped on it, it does not guarantee the upper assembly is rated for the same caliber, because the upper and the lower receiver in the same rifle can, and frequently do, come from different manufacturers, particularly with rifles sold to civilians or second-hand rifles. In more practical terms, As of 2010, most AR-15 parts suppliers engineer their complete upper assemblies to support both chamberings in order to satisfy market demand and prevent any potential problems. Effects of barrel length on velocity. Barrel length helps determine a specific cartridge's muzzle velocity. A longer barrel will typically yield a greater muzzle velocity, while a short barrel will yield a lower one. In the case of the 5.56 NATO M193 ammunition loses or gains approximately 25.7 feet per second for each inch of barrel length, while M855 loses or gains 30.3 feet per second per inch of barrel length. Related cartridges. P.O. Ackley created an improved version of this cartridge, called the .223 Ackley Improved. It has the straight sides and steep shoulder, typical of the Ackley design improvements, yielding about 5% extra case volume. This, in turn, provides longer case life, less stretching, and up to 100 foot-per-second faster velocities. Wildcat cartridge developers have for a long time necked this cartridge up to create the 6mm/223 or 6A, 45mm. At one time this round was very popular for varminting and competition, but has been replaced by current popular competition cartridges using short, fat cases, such as the 6mm PPC and the 6mm Norma branch. The Thompson Center Older family of Wildcat cartridges are also made by necking up .223 Remington cases, for use in the Thompson Center Contender target pistol. See also, .30 RAR, 5mm caliber, Delta L problem, list of rifle cartridges, table of handgun and rifle cartridges, sectional density, references. External links. .223 Remington Cartridge Guide by AccurateShooter.com, A 5.56A, 45mm Timeline by Daniel Waters, Ballistics by the Inch. .223 Remington Results.